So now that we understand how to work with scatter plots, we're going to talk about something that's referred to as the line of best fit. Get my picture out of the way. So a line of best fit is a straight line that's used to express a relationship between two sets of data in a scatter plot. In other words, it shows the trend of the data. So we've talked about the correlation. This shows generally the expectation. So as we talked about, the more sleep you get, the better your score. This kind of predicts if I had this much sleep, what type of score could I expect? Okay, so this can also be used to predict outcomes that you don't see in the data. So maybe the data you collected doesn't show you enough information. As we look through, how do we go about doing this and making certain that our line that we're drawing is definitely going to work? So you're going to determine the correlation between the two sets of data. Is it positive? Is it negative? Is there none? Then you're going to do your best to have the line go through the center of your data points. Try to have an equal number of points both above and below the line. So let's just look at some good examples first, because you can't understand how to draw it if you don't know what to look for. So it says the following scatter plot shows the comparison between the time of day and the temperature in Alaska. Which option correctly draws a line of best fit? So here's our original. Oops, I just wrote on that one. Here's our original data, and you can see this negative trend. So what we're looking for is a line that's going in the center of the data. This one's definitely out because it's going positive. That's not at all what we're looking for. As we look at D, since I've already written on it some, it starts well below the points and then goes away from the points. That's not what we're looking for either. So now what we have to decide is, do we like the look of A or the look of B better? Ideally, if your line is drawn, you should have about the same number of points above the line as you do below. It's not always something that's possible, but that's what we look for. This looks pretty good. As we look over here, you're going to notice that it's very close to the edge of this data, almost completely above it. And as you go further and further down, it's almost only below it. This has a nice mix of both above and below. So A is our best option. Looking at another example, it says the following scatter plot shows the comparison between the number of customers at a restaurant and the number of staff working. So it looks like the more customers you have, the more staff you need. Which option correctly draws a line of best fit? So again, let's look at A. A has everything kind of sticking just to the outside. We want it to be more in the center. This is kind of in the center, but only really here. It goes across it instead of with it. So that one's out. This one does what we're looking for. I'm going to say yes, but I'd like to make certain everything looks good. And by the way, the correlation between this seems to be more positive. This line is drawn negative, so we know that can't work. So C is a great choice. A couple more examples. The following scatter plot, sorry, my picture's in the way. There we go. The following scatter plot shows a comparison between a child's age and their height. It seems the older a child gets, the taller they get. Which option correctly draws a line of best fit? Well, again, this is more of a positive correlation, so we expect to see it going through the points and mostly to the center of them. This does the opposite. This is going from the origin up, which is great, but our points aren't, so that one's out. This one goes kind of through the center, but it seems to be going at too steep, while this one goes right through, so this is your best choice. A few more. Let me move my picture down. That seems to be the story of my thing. All right. The following scatter plot shows the comparison between the temperature and the number of people wearing jackets. So it seems that the colder it gets, the more jackets you see. Which option directly or correctly draws a line of best fit? We got a negative correlation happening here. This is way off to the one side. This doesn't do it. This one's going positive while our dots are going negative. This one stays to the bottom of it. That's not great. And look at how nice and centered this one is. That's what we're looking for. All right. The following scatter plot shows the comparison between the number of hours and customers at a restaurant. Predict how many customers there will be at the restaurant after 5 hours. So currently, as we look at 0 hours, there's 50 customers. At 1 hour, it seems to be coming down to about 40 customers. At 2 hours, 30 customers. At 3 hours, we're down to 20. At 4 hours, we're at 10. So if we continue this trend, looks like we're going to be at 0 customers. And approximately how many customers are in the restaurant after 1 hour? Based on their line of best fit, we would say 40. Obviously, the data shows otherwise. All right. Our x-axis shows hours worked. Our y-axis shows dollars earned. And this is Jim's earnings versus his hours worked. So it says the following scatter plot shows the comparison between the number of hours Jim has worked and his dollars earned. Predict how much money Jim will earn if he works for 11 hours. So as we look, he's kind of moving along. It's very close that it's going. So at 9, well, the last time we really have any data is at 8 hours. At 8 hours, it seems like he was making closer to $64, maybe about $62. At 9, it seems like we're up to the middle of that, so about $68. At 10, we're just at about $72. So it looks like at 11, we're between 72 and 80, but a little closer to 80. I would say $78. Again, that's just us guessing. Approximately how much money has Jim earned after 7 hours? So again, up at 7, you're just past the 56. I'd say about $58. And that's it. We can use that line of best fit to help us.